Hello everyone, welcome to PCB e-classes. Welcome back to DC Machines lecture number 4. In the previous lecture we have discussed about the basics of the DC machines, as well as we have discussed about some of the constructional components of the DC generator. Moving to the next slide, we will be seeing what are the topics we have covered till now. Which we have covered in the previous lectures are the basics parts. Under the basics we have covered about the Faraday's electromagnetic induction law. Next one is about the magnets we have learned. Next is that is Fleming's right hand rule, Fleming's left hand rule, right hand thumb rule, screw rule, and depending on the sensing of the coil, how the north pole and the south pole of an electromagnet is created. Those basics we have covered it. Then after we came for the basic applications of the generator, motor and the transformer, and then after we went for the DC generator part, whose first we have visualized the internal diagram of the DC generator. Then we have came for the constructional details of generator, and then after we have went for the components. We have covered the magnetic yoke, that is one of the component of the DC generator. Coming to the second one, that is a pole core and the pole shoes. What are pole core and the pole shoes? Pole core or the pole shoes are curved in nature, which are fixed to the magnetic frame of the yoke with the help of the nut and the bolts. These are basically the electromagnets over which the winding is kept and a supply is given, due to which this behaves as an magnetic pole, that may be north pole, that may be the south pole, depending on the direction of the or the sensing of the coil. Now the poles in DC generators are called salient poles because they are projected inwards. Next, these are made up of cast steel or cast iron with laminations. Why the laminations are given? Because by giving the laminations we can reduce the eddy current losses. Now let us see what are the functions of the pole core and the pole shoes. It supports the field winding. The field winding, that means the winding which we are giving over the pole in order to form into an electromagnet. It supports the field winding which are wound around the pole core. That is the first function it does. Second one, it provides uniform distribution of magnetic flux to the armature. Third one, it helps in increasing the cross-sectional area of the magnetic circuit, which in turn reduces the reluctance of the magnetic path. Visualize the pole core and pole shoes with the help of the diagram. Now I have given on the left side the side view and on the right hand side the front view. Let us see what is a front view, how it looks. Now this is a pole core, this is a pole core and the pole shoe which I have represented on the right hand side. Here you can see it's a pole core and this is a pole shoe which is curved in nature. Now how it is made? It looks like this, but it is generally made up of thin sheets, thin cast iron or cast steel sheets. Let us see the side view. Now it is one sheet, right? By combining a numerous number of thin sheets, a pole core and pole shoes are created. You can see in the left hand side the thin sheets are combined to form a pole core, and over that, in order to make them electromagnet as well as creating the north pole or the south pole, we are providing the winding through which the current flows. As soon as the current flows, this behaves as an electromagnet and gives the polarity as north pole or the south pole depending on the current direction. Now if the current direction is in this way, then the polarity will be different. If the current direction is reverse, then the polarity will be also different. Combination of these sheets forms this pole core, and the windings which are given around the pole core is said to be the field winding. Now see on the front view side, I am giving the field winding over the pole core and I am giving the current direction. You can see here. What is the current direction? Current direction is from the right to the left. Now if I'll apply the right hand thumb rule, then its magnetic field direction will be outward, in which the magnetic field direction is outward, then this pole will be having the polarity as north pole. Now if the current direction is reversed, such as you can see in the right hand side, from left to right, applying the same right hand thumb rule, the magnetic field direction will be inward, thus its polarity will be south pole. Thus in this way the north pole and south pole polarity are created with the help of the electromagnet as well as with the help of the field winding current direction. We have seen the pole core pole shoes construction, how it is made and how these thin sheets are combined to form the pole core and the pole shoes. Now let us visualize or justify the reluctance part which I have dealt in the previous slide. Now see here, this is a pole core and the pole shoes. In the left hand side you can see it is a curved surface, whereas on the right hand side you can see the flat surface. What is the difference between them? Let us see. Now if it is a flat surface, then the surface area becomes very less, whereas if it is a curved surface, the surface area is more. So as we know, the reluctance or the resistance both are dependent on the area. Now if we can say that it is inversely proportional to the area. Area increases, then the reluctance will be definitely decreasing in nature. So which part is better? Naturally the curved surface is better than the flat surface because its area is more, thus the reluctance will be less and it allows more flux to pass through it. Next, coming to the field winding. Now what are the field windings? Basically these are the copper wire wound pole core and placed over each pole core to produce the required magnetic field, thus called to be the field winding or exciting coils. It always requires a small DC power to produce a strong constant magnetic field. These coils are connected in such a way that when DC current flows, the respective poles get magnetized and produce the required flux. We have seen earlier in the internal diagram of the DC machine. In the figure you can see here, we have represented the field windings here. This is a pole, north pole, south pole, north pole. These are the poles actually. Over that the windings which are given, those are said to the field winding. Separately I will be explaining this one. For example, I have taken this one as a pole core, and if I am giving the windings, then these are said to be the field winding. These are the copper wires. If I allow the current to pass through it, then this will magnetize the pole core. Thus these windings are said to be the field winding. This is all about the lecture. In the upcoming lecture we will be seeing the other parts of the DC generator. Thank you.